In the process known as cellular respiration, we first start with the step of glycolysis, where we start with a 1,6-carbon glucose molecule. By adding 2 phosphorus molecules of glucose, we convert the glucose into fructose. We use 2 ATP molecules to perform this process. An enzyme then comes along, and the fructose is broken down into 2 3-carbon sugar isomers. The 2 3-carbon sugar isomers are changed by NAD+, which is oxidized into 2 NADH. Various enzymes come into play and continue to rearrange the molecules by shuffling the phosphate groups and hydrogen, and we are left with 2 net ATP molecules, 2 H2Os, 2 pyruvic acids, and 2 NADH molecules. Now, we enter the formation of acetyl-CoA that occurs in the mitochondrial matrix, where a carboxyl group is then snipped off of one of the pyruvates and released as a molecule of carbon dioxide, leaving behind a 2-carbon molecule, which is oxidized, and the electrons lost are picked up by NAD+ to form NADH. The oxidized 2-carbon molecule is then attached to coenzyme A and an organic molecule derived from vitamin B5 to form acetyl-CoA. Now we enter the Krebs cycle, which occurs in the mitochondrial matrix, where acetyl-CoA merges with oxaloacetic acid, which is a 4-carbon molecule, in an enzyme-catalyzed reaction where citric acid is formed, and then oxidized over several steps where it becomes oxaloacetic acid once more. It forms 2 CO2, 3 NADH, and then the ADP becomes ATP, and FAD is oxidized into FADH2. This process occurs with the other pyruvates, so everything produced is multiplied by 2. So by the end of the Krebs cycle, we get 6 NADH, 2 ATP, 2 FADH2, and 2 NADH from the preparatory stage. Currently, we have 4 ATPs, 10 NADH, and 2 FADH2, which will be used in the electron transport chain. Electrons from NADH and FADH2 are then transferred to the next step of cellular respiration, the electron transport chain. The electron transport chain is comprised of 4 protein complexes that pass electrons down the chain. A 5th protein complex serves to transfer hydrogen ions back into the matrix, and these complexes are embedded within the inner mitochondrial membrane. NADH transfers the electrons to the complexes, resulting in positive hydrogen ions being pumped across the inner membrane. NADH is then oxidized into NAD+, which is recycled back into the Krebs cycle. Electrons are transferred from complexes to a carrier molecule. Eventually, the carrier molecule passes the electrons to the final protein complex in the chain, complex 4, with 2 positive hydrogen ions being pumped across the inner membrane to an oxygen molecule, causing the molecule to split. The resultant oxygen atoms grab positive hydrogen ions to form 2 molecules of water. ATP synthase moves positive hydrogen ions that were pumped out of the matrix by the electron transfer chain back into the matrix, and the energy from the movement of protons into the matrix is used to generate ATP by phosphorylation of ADP. A total of around 32 ATP molecules are generated in the electron transfer chain in oxidative phosphorylation.